Okay, so slopes of lines is what 3-5 is. We start with the definition of the slope of a line. So the slope of a line in a coordinate plane is a number that describes the steepness of the line. It's the ratio of the change in y, or your vertical change, to the change in x, or your horizontal change. You'll also see it as, it's Nate's turn, as rise over run. So if you're counting from a graph, you would count the vertical change, which is your rise, and the horizontal change, which is your run. And then if you're given 2 points, you can use that little formula that tells you that the slope would be the y2 minus the y1 over the x2 minus the x1. So if you look at this graph, right, so this is from a graphed line. If I wanted to find the slope of the line, I would pick 2 points that are obvious points, so those little red dots are those obvious points. And then I want to do rise over run. So I would count the vertical distance over the horizontal distance. And it doesn't matter which one you pick. So if I were to start at this bottom one and work my way up to the top, that would be a 1, 2, 3, 4, 5, 6 vertical change. And then a 1, 2, 3, 4 horizontal change. And then 6 over 4, every fraction you write in here should be reduced, so those can be reduced to 3 over 2. If I went the other direction, so now let's say I start at this point and I work my way down to this point, my signs change. So if I do a vertical distance, I would do 1, 2, 3, 4, 5, 6, and that's down, which would mean -6. And then count horizontal, 1, 2, 3, 4, and that's left, so it would be a -4. I'd end up with -6 over -4, which still reduces to 3/2. So it doesn't matter which point you pick to start at. You get the same answer. You just always want to make sure that your fractions are simplified. Questions so far? All right, so example 1 says use the slope formula to determine the slope of each line. So you have 2 options here. You can either count like we just did, okay, or you can pick 2 points on that line and plug it into the slope formula. So if I was to pick 2 points for the line, and I'll do A first. So let's say I'm trying to find the slope of AB. I would figure out what's the coordinate for point A and what's the coordinate for point B. So if I did A, you're going left 2, so the x coordinate would be -2, and then up 1, 2, 3, 4, 5, 6, 7, and that's the y coordinate. And then if I want to find the x and y coordinate for B, I'm going right 2, that's the x coordinate, which comes first, and then up 1, 2, 3, 4, 5, 6, 7, that's my y, +7.
Is that 3 or 7? That's 3.
Oh, I'm sorry, that you're totally right. That's a 3. Just making sure you're paying attention. A 3, 7. Okay. So now when I plug it into my equation, so I'll show you both ways, the counting and the plugging in. Now when I plug that into the equation, which is y2 minus y1 over x2 minus x1. And I make this x1 and y1 and this x2 and y2, and it doesn't matter which ones you make the 1s or which ones you make the 2s, as long as you're consistent. Then I would get 7 minus 7 over 3 minus a -2, which is 0 over 3 minus a -2 becomes 5. What's 0 divided by 5? 0. So if the 0 is in the top, it's 0. If it's in the bottom, it's what?
0.
Nope. What happens if 0 is in the bottom?
5.
It's undefined. So if I had 0 over 5, it's 0. If I have 5 over 0, it's undefined. You cannot divide something by 0.
Wait, so
Yep.
so if there's 2 points and they're on the same line, can you tell it's already undefined?
So if it's horizontal, which we're going to get to in a second, horizontal would be 0 and vertical would be undefined. So that's one way to do it. The other way would have been to count. So if I count from right to left here, my vertical change is 0, right? And then my horizontal change would be 1, 2, 3, 4, 5. And I'd still get the same thing, 0 over 5, which is 0. Sometimes you're going to get given the graph, in which you could choose between the points or the counting. And sometimes you're just going to get the points, and you'd go straight to the formula. So just make sure you know how to do both. Go ahead and finish those. So find the slope of AC, use either way, and then find the slope of AD, again, whichever method is your preference.
Wait, what?
What does wait what mean?
I thought you like find the points.
You could do either way. You can either count it out or you could use the points.
Really?
Yes.
She just said, oh man.
What's the magic number? Do I have to say the same thing 4 times for everybody to hear it? We think it's 4 because I'll just say it 4 times like immediately. Do you think it's 4? Okay. The difference is, Ryan, so to answer your question, the difference is sometimes you're going to get given the graph, and so you have that choice. You could either figure out what the points are, or you have to count, or you might just be given the points without the graph. And so it's more work to go through the process of graphing it and then counting. That's when it's going to be easier to use the formula. So when you have the graph, it's probably easier to graph it, to count it. But if you don't, you need to make sure you know how to do the points too. Okay, and then A to D, 1, 2, 3, 4, 5, 6. That's a negative 6, but there's no left or right. And we just said divided by 0 would be undefined. Everybody good? Okay. Questions on those of you that might not have gotten it correct? Yep.
How can you tell? You always start down?
No, it doesn't matter which way you start, because if I had gone up and left and right, it would have been a positive 6 over 0, which is still undefined.
So the answer is just undefined?
Correct.
So if it's over 0, it's always undefined?
Correct. All right, so determine the slope of JK through J, 3, 1, and K, 2, negative 1. So this is going to be when it's going to be easier to use the equation than to graph those points accurately and count it. So I'll make J the 1s, although it doesn't matter as long as you make them the same. So whatever my X is, my Y has to have that same number. And then this would be my Y, or X2, Y2. And then the formula is y2 minus y1 over x2 minus x1. So negative 1 minus 1 over 2 minus 3, and I get negative 2 over negative 1, which is 2. All right, so there are 4 types of slope: positive, negative, 0, and undefined. Positive rises as you move to the right. So if you've ever been on a treadmill and you start to mess with the incline, think of that as slope. The higher that number, the steeper it gets. And then if you're walking down a hill or you have a treadmill that can decrease your incline to a negative number, now it's like walking down that hill. It would be a negative. It would be falling as it moves to the right. When your treadmill is at 0, what does it look like? It's flat, okay? So horizontal lines, which horizontal actually has the O's in it, if you want to memorize it that way. This is an O, and it is 0 for your slope. And if you could somehow manage to get your treadmill to go vertically, mine does not, but let's say yours does, there'd be no slope to grip, okay, which is undefined, or no slope. A line that has a slope of 0 will be a y equals a number, and we'll have no x. So like if this is here, this would be a y equals 2. You'd be missing the x coordinate of that line. And a vertical one, like let's say that this is also 2, would be an x equals without a y. So you'll see this when we get into our equations a little bit further.
Could it be on the other side too?
Yeah, it could be positive, negative. It could even be 0 and be the axis.
Oh.
It's just that horizontal would be 0 and vertical would be undefined. So, all right, a rate of change. So one interpretation of slope is called a rate of change. If y represents miles traveled and x represents the time in hours, the slope gives the rate of change in miles per hour. So the top number would be miles, let's say. The bottom number would be hours. So if I said I traveled 100 miles in 2 hours, then I would do 100 over 2, which reduces to 50 over 1, or 50 miles per hour.
It's like a unit rate.
Yep. All right, so this one said, Justin is driving from home to his college dormitory. At 4 p.m., he's 260 miles from home. At 7 p.m., he's 455 miles from home. Graph the line that represents Justin's distance from home at a given time, and then interpret the slope of the line. So I'm going to help you with this. I'll help you set up the graph, okay? Let's say that the bottom is the time, which is your x-axis, and the vertical is your miles from home, or distance. So whatever unit we set up on the bottom just has to be consistent. Let's say we start this at noon, at 12 p.m. Then this would be 1 p.m., this would be 2, this would be 3, this would be 4, 5, 6, 7. And then let's say the vertical is our distance, but we don't want to start at 0 and go all the way up to 260. So let's jump a little bit. Let's say that this is 100. This is 200. Actually, but let's make sure we get. I want 455 to be on there and nice and easy. Okay. So let's do 200, 250, 300, 350, 400, 450. That would be 500. So at 4 p.m., he's 260 miles from home. So if I did 4 p.m., I go over to the x where it's 4, and I go up to 260, which is about there, okay? So we're saying it's 4 p.m. and 260 miles from home. And then at 7 p.m., he's 450 miles from home, 455, sorry, miles from home. So 7 p.m., 455. So this is what my line would look like if I connected those points. It says find and interpret the slope of the line. So by finding it, I would do my y2 minus y1 over x2 minus x1. I can make this my x1, y1. I can make this my x2, y2, and I get 455 minus 260 over 7 minus 4. And then I would do 455 minus 260 which is 195 over 3. Yep.
Are we gonna learn about x-intercepts?
Not yet. Yeah. And then I can even take that a step further because 195 is divisible by 3, right? If I add up my digits, 1 plus 9 is 10 plus 5 is 15, which is divisible by 3. So this is 65. The check for 3's, add up your digits and see it's divisible by 3, right? So 1 plus 9 is 10, plus 5 is 15. Is 15 divisible by 3?
Yeah.
Yeah, so then I know it's divisible. And then I just did 195 divided by 3. It would be 6 times. And then 5 times. So it's 65. So it says first find the slope, which would be 65. But then it says interpret the slope. So what does this mean? What was that top number representing? What's the top? What's the left side representing? Distance, and we use that as our y. What's the bottom representing? Time. So the distance was in miles, the time was in hours, right? Which would say that this is a miles over an hour kind of a thing, right?
What's the same like what the numbers from like?
The 4 and 260 and 7 and 455. So this is 65 miles per hour. So that tells you how fast he was traveling, right? This is when your parents bust you for speeding. They figure out how far you got in how short a time.
There's an app that tracks you.
All right, so there's 2 theorems dealing with parallel and perpendicular lines, okay? Hopefully these make sense logically, okay? If I actually draw them out, they should make perfect sense. It says 351, which is the parallel lines theorem. It has a name, so you don't have to write a big long explanation, but if you don't remember the name, then you can write that big long explanation. But it says in a coordinate plane, 2 non-vertical lines are parallel if and only if they have the same slope, and any 2 vertical lines are parallel. So you're basically saying that 2 lines that have the same slope are parallel. So if you thought about, if I took a point and I went up 1, 2, 3 into the right one and I graphed it, and then I took another point and I did the same thing up 3 into the right one, these would have the same slope and they'll never intersect because you would always be going up and over the same distance. So same slope or parallel. That's all that says, which again, hopefully that's not, you hopefully heard that in algebra too, but algebra also, but it's now in theorem form.
What does that say?
Same slope are parallel. So lines with the same slope are parallel. That's 2 lines for parallel. Yeah. And then perpendicular lines theorem says in a coordinate plane, 2 non-vertical lines are perpendicular if and only if the product of their slopes is -1. In plain English, this means that their slopes are opposite reciprocals. What are opposite numbers?
Integers.
What would be the opposite of -3? Positive 3. So what's happening there? What are you doing to those? You're changing the signs, right? So this is the opposite sign. One would be positive, one would be negative. And what's a reciprocal? What's the reciprocal of 2? Nope, not opposite.
Half.
2 would be 1/2. How about 2/3? What's the reciprocal of 2/3? 3 over 2. So we're flipping the number, right? That's the reciprocal. So you're going to flip it and change it. Flip it and change the sign.
Wait, when it's a reciprocal, you flip it, right? But do you also make it negative?
So technically the reciprocal part doesn't change the sign. But because perpendicular, we're saying it's the opposite and the reciprocal, you flip it and you change the sign. So if the question was just what's the reciprocal, you leave the sign. But if I tell you that a line has a slope of 1/2, what's the perpendicular line slope? You flip it and you change the sign. So it'd be -2. So if I had the slope of a line is 2/3, what's the slope of a line that is perpendicular to that line? -3 over 2. And if I multiply those together,
Good job.
I get -1, which is what this is saying, okay? So if the question is, what should the product be of the 2 perpendicular slopes, it would be -1. If you're just finding it, all you have to do is flip it and change the sign. So graph each pair of lines and then use their slopes to determine whether they're parallel, perpendicular, or neither. so what I did is just plot my points so far. So 0, 2, remember the x comes first. You're not moving left or right at all, but you're going up 2. That's your u. V was -1, -1, so I went back 1 and down 1. 3, 1 is x, so I go to the right 3 and up 1. And then y is -3, 3, so you go back 3 and up 3. Then it says to find the lines uv, which would be here, and xy, which would be here. So hopefully the graph helps you at least narrow down what do you know automatically these are not.
Parallel.
They're definitely not parallel, okay? They appear to be perpendicular, right? They look like that's a right angle. But unless you had a protractor, which you won't if you're doing this on a quiz, you won't have a protractor to measure that that is exactly 90 degrees, then you have to follow this up by checking their slopes. So I'm going to find the slope of uv. I'm going to take these 2 points and plug it into y2 minus y1 over x2 minus x1. -1 minus 2 over -1 minus 0. And I get -3 over -1, which is 3. And then find the slope of x, y. Again, using these two this time. y2 minus y1 over x2 minus x1. 3 minus 1 over -3 minus 3, which is 2 over -6, -1/3. So if they're perpendicular, what are we looking for their relationship to be?
Reciprocal.
Reciprocals and opposite. Are these opposite and reciprocals? Yep, so we can say that these lines is perpendicular to x, y. Perpendicular is that upside down t. How do we know? Because their slopes are opposite reciprocals. So the sign is different. One's positive, one's negative. And reciprocals, meaning it's flipped. 3 flipped would be 1 over 3.
So Miss, do you have to do like, do you have to draw up the graph, or can you just?
I mean, this question actually said graph it. So if on your quiz or test it said graph it, it will give you the graph where you're graphing it. Do you have to determine that? No. You could just find their slopes and then look at them. But it just depends on what it asks for. Questions on that one? Okay, so I graphed point G, which was -3, -2, H, which was 1, 2, I, which is -2, 4, and J, which is 3, -4. And now I want to find the slope. So for GH, I would use these two, y2, which would be 2 minus a -2 becomes +2, and then 1 minus a -3 becomes +3. And this is 4 over 4, which is 1. And then IJ, I'm going to use this one and this one. Y2, which is -4, minus Y1, which is 4, over 3, which is your X2, minus your X1, which is a -2. 3 minus a -2 becomes +2. And I get -8/5. So these two are not the same, which means they're not parallel, and they're not the opposite reciprocals, which means these would be neither parallel nor perpendicular.
That's you.
And example 6, again, plotted my points, and then use the points to find the slopes. WX had -3 over 0, so what would I say that slope is?
Undefined.
Undefined, good. And then YZ is 0 over 6, which would be? 0, okay? So we can't really do opposite, reciprocal, and 0 and undefined, but if any horizontal line and any vertical line are going to meet at what? What's it going to look like if they meet? Would they be perpendicular, parallel, or neither? Perpendicular. So any horizontal and any vertical line are going to meet. Okay, the segments here don't meet, but if I extend these lines out, they meet, and because they're slopes, one is vertical and one is horizontal, these would be perpendicular. And that's that upside down T, perpendicular. Sophia. Like to